All right, so what I want to take a look at right now is what's the origin of the 30, 60, 90 and the 45, 45, 90 triangles. Okay, so let's take a look at the 30, 60, 90 first. I'm going to start out by drawing what's called an equilateral triangle. Equilateral means all the sides are the same. And if you take a look at the equilateral, if all sides are the same, that means all the angles are going to be the same. And the sum of all the interior angles of a triangle have to add up to be, drum roll, 180 degrees. So this guy is 60 degrees. Same with that guy. Same as this guy. Okay. So 1, 2, and 3. Now, I drew a line down through this angle because I'm going to cut it in half. And when I cut it in half, this angle now becomes 30 degrees. This angle, we can put our little square in there to show that it's 90 degrees because all 4 angles of a square are 90 degrees each. And that actually gives me a total of 360. So every time I go from a triangle, which the interior angles are 180, every time I add a side, the total of the interior angles goes up. But that's for a whole nother lesson. Now I'm going to also come back and say, well, let's make this side right here length 2, which means this side is of length 2, which means this entire side is also a length 2. But I cut this bad boy in half, so I'm going to make this side of length of 1. Using the Pythagorean Theorem, I'm going to give this the value, we'll just call it x. Pythagorean Theorem says 1 squared plus x squared equals 4 squared. 1 plus x squared, excuse me, this is a 2. Hope nobody got too excited. 2 squared, how's that? Yeah, so this now equals 4. Subtract 1 and take the square root of both sides, and I finally get x is 3. So this guy right here, the missing side of the triangle of the 30, 60, 90 is going to become the square root of 3. So what do I have? I have a triangle that looks like this. This is 30. This is 60. This is 90. This is 1 across from the 30. This is square root of 3 across from the 60. And this is 2 across from the 90. And as the angles get bigger, even though they increase at a constant rate, these lengths do not increase at a constant rate. Okay, this is 1. This is a square root of 3, which is somewhere less than 2. And this is 2. So we refer to our 30, 60, 90 triangle in proportion, but not really proportion because it's not consistent, but 1 square root of 3 and 2. So how would I use this? Well, let's say I want to find an angle measure, and we're going to go back to coordinate system. I'm going to put in an A, S, T, C. Some of you have heard of all spiders taste crunchy. Some of you have heard of all students take calculus, but that's scary and people forget that. So now I'm going to take an angle measure, and I'm going to say, let's go with 150 degrees. So if I start and I rotate around and I get to 150 degrees, I'm now going to draw a triangle. Now, based off of this point right there, I'm going to fill in the values of the triangle. So if this is 150 degrees, that means this has to be 30 degrees because 150 and 30 equals 180. That becomes 90, which by default means this is going to be 60 degrees. Now, if I start putting in values, again, across from 30 is 1, across from 60 is the square root of 3, and across from the 90 is the 2. So the location of this point right here would have the coordinates negative square root of 3, positive 1. So that point is negative square root of 3, positive 1. All right, so now if I wanted to use the 150 degrees, let's say I wanted to find the tangent of 150 degrees. This ASTC tells me that only the sign is positive in the second quadrant. So I already know my answer better be negative. So 150 degrees, I'm going to use the reference angle 30, because that is the supplementary angle to 150. Tangent is opposite over adjacent. So it's going to equal 1 over negative square root of 3. And of course, we don't want to leave these with a root in the bottom. Final answer is negative square root of 3 over 3. So when I'm asked to find something like the tangent of 150, I draw a coordinate system, I go over 150 degrees, and I realize I'm going to use the reference angle of 30 and draw my 30, 60, 90 triangle so I can put in the values. 45, 45, 90. Again, we're going to do the same thing. We're going to draw a triangle, but this time, I didn't do so good. This time, this is 45. This is 45, which means this is 90. If this guy is 1, then this guy has to be 1. And again, I'll call this R. 1 squared plus 1 squared equals R squared. 1 plus 1 equals R squared. 2 equals R squared. R equals the square root of 2. So this guy becomes the square root of 2. So just like we looked at over here, the 30, 60, 90, we had values. We're going to have the same thing for the 45, 45, 90 triangles. Make them degrees. It's going to be 1, 1, square root of 2. So a lot of times knowing where these guys come from give you a better understanding of dealing with them. So let's say now I want to take the cosine of 225 degrees. I draw my coordinate system. I go 90, 180, there's 225. Here's my reference angle. Okay, 1/8. This happens to be a 40. This happens to be a 40. So if I start putting in across from both the 45s, I put 1. And I know this is going to be the square root of 2. This point at the end of this line would be coordinates -1, -1 by location. Again, all spiders taste. The only thing over here would be positive, would be a tangent. Okay, so I need the cosine of 225. I come to the 45. Cosine is adjacent over hypotenuse. -1 over the square root of 2. I rationalize it. Means I'm going to multiply top and bottom by the square root of 2. And I end up with negative square root of 2 over 2. Okay, 2 quick examples. Where did the 30, 60, 90 come from, and how can I use it to find values larger than 30, 60, 90 and 45, 45, 90. I hope that helps.